Okay, so the weight of a Thanksgiving turkey is normally distributed with mean 19.4 pounds and has a standard deviation of 1.5 pounds. Let's X be the weight of the turkey, dead one. So what is the probability that X is equal to 19.6?
0.
Why? Enlighten us, Benson.
You can't have a probability of an exact value in a continuous distribution with density.
Because we cannot have a probability, a non-zero probability for an exact value with continuous distribution. So with discrete such as binomial, of course we could find an exact probability x is equal to 1, x is equal to 2, and so forth. But we cannot do that with continuous distributions. To be fair, at this level of college, we can't. But you did limits and a whole bunch of things. We can come up with a probability. Even then, it is not going to be a very large value. It's likely to be a very small value. So it's close to 0. Another way to think about it is with continuous distributions, probabilities are always cumulative because if they correspond to the area under the curve. And area of a single point is 0. The point has no area. So we have defined the probability that the weight of the turkey is greater than 14.34. So I always advise my students to draw this curve before going to the calculator, because there are some standardized exams where you don't get to have a calculator, you just have to think. So think carefully. What is the mean, or that point in the middle? What is the value of that point?
19.4.
19.4. Where does 14.34 lie?
To the left.
What?
To the left.
To the left, okay. Just like Beyonce. Okay. So the area under the curve would be the answer to this question. It is a cumulative probability. Even before you start the problem, you should kind of know the answer. Could the probability be less than 0.25? Jesse says no. Why not?
Because most of the area is to the right of 14.3.
So to the right of 19.4, we have about 0.5, or exactly 0.5, 50%. To the left, we have 0.5, and you already have accounted for 0.5. So whatever answer that you have cannot be below 0.5. So you can use process of elimination and say, oh, this just is not feasible, and eliminate all answers that are less than 0.5, and look for those that are greater than 0.5. So the area starts right there, and it keeps on going that way. So that's the lower endpoint of the area. Upper endpoint, where does the area end? Somewhere, who knows? I'm just going to call it positive infinity. If you're taking AP calculus or, AP statistics or statistics in the past, most instructors have a tendency to say, okay, just pick a large number. And they would say, oh, pick 10,000 or 20,000. While it will work for certain problems, with certain problems, it would actually cause issues because if you change the scale of the data itself, then a number of 10,000 is not large enough. So I tell people to always put infinity or negative infinity on the other side. This way you don't have to worry about the scale of the sample. By scale I mean, instead of 19.4, what if you had 190,400? And in that scenario, you cannot have an upper bound of 10,000. You have to think and say, okay, I need to put 1 billion. So instead of working with that mentality, I simply say put infinity. Good so far? Okay. So we know the answer has to be greater than 0.5. And the lower endpoint of the area is 14.34. Upper endpoint is infinity. So we are trying to find a cumulative probability. So press second. Mars. Number 2. If you have the new model of the calculator, it should say lower, upper, mu, sigma. Yes? So if you have the older version, the order is the same, you just don't have lower, upper, mu, sigma. We're just going to type the numbers in the same order. So the lower was 14.34. The upper is infinity. You cannot put infinity in a calculator, even in a computer. So press second, comma, get a weird small cap E, and 99. Lower or small caps E, 99 would mean positive infinity. If you put negative and then type that in, you get negative infinity. Comma, the mean here is 19.4. And the standard deviation is 1.5. Good. Close paren. Enter. 99.96%, that's if I went and bought a turkey, it's going to weigh more than 14.34 pounds based on this data. Does that make sense? So the original data here, we used it directly and we had 14.34, E99, the mean and the standard deviation. If I have to use the z-score, we can use this value, but we have to plug in 0 and 1. I'll show you that. So the moment we convert the observation to a z-score, the mean would change to 0, the standard deviation would change to 1. So you could use the same thing, second, Mars. You have to use the z-score now, you can't use the observation, so negative 3.37, comma, E99, comma, mean is 0, standard deviation is 1. You will get the same answer.
Why?
Slightly off, huh?
Why do you get the same answer?
We went over this, oh wait, you weren't here last time. We went over this last time. No matter what normal distribution we have, if we subtract the mean and divide by standard deviation, we are converting it to a standard normal, which will always have a mean of 0, standard deviation of 1. It doesn't matter how you do it these days because we have a calculator. Back then, we had to rely on a chart. So I'll show you how to do this with the chart also. The table is in the appendix, and we have a value of the z-score, which is negative 3.37. And if you look at the graph, it is going to tell us the area below whatever z-score that you have. So you've got to be careful. The calculator, we just put it the way we wanted and we got the answer. But if you use the chart, it is always going to give you the area below. What we have is negative 3.37. So scroll down to negative 3, which is right there. And 3.3, which is right there. That would give you the first decimal, and then 0.07 to that you would get negative 3.37. Agree? It's bad math, I know, but that's how you interpret the chart. So negative and 3.3 plus 0.07, 3.37, negative, back. Good? And go along, and the value is 0.0004. That is not the same answer that we had in the calculator. Why?
Because you have to subtract it from 1.
We have to subtract it from 1. Again, the chart, this particular chart, gives you the area below the z-score, not above, but this is conventional. So the area below is 0.0004, which implies the area above has to be 1 minus that, and 1 minus 0.0004 is 0.9996. And that's what we had. Does that make sense? Okay. Probability x less than 18.24. Even before we start, do we expect this probability to be greater than 0.5? No. Clearly, this observation is below the mean, so definitely less than 0.5. If we found a z-score, would it be positive or negative? It is below the mean. Negative. So, again, if you want to convert it to a z-score, use the chart and do all that, go for it. But since we have a calculator, less than 18.24, you don't have to do this, but it will help. What is the upper end point of the area? 18.24. And what is the lower boundary for the area? Negative infinity. So negative E99, 18.24, 19.4, and 1.5. What do we get?
0.2196.
Did we get 0.2196? So there is a 21.96% chance that if I went and bought a turkey, its weight would be less than 18.24. Who would like to answer D? She said no.
Well, if we're dealing with the greater than or equal sign, the probability that something is equal to something is 0. So the probability that something is greater than a value is equal to the probability that something is greater than or equal to a value. So we're gonna get the same answer as in part B.
How many somethings did he use?
Like 4.
He did use 4. The entire time I was focused on something. He didn't get it, but that's okay. This is the same as greater than 14.34. He's absolutely correct. Why? Probability of x greater than or equal to 14.34 would mean greater than or equal to. But we know that the probability at a single point is always 0. So whether you put that equal sign or you don't put that equal sign, it doesn't matter. That answer is the same as that answer. So you have 0.9996. I know that it's not 19.8 maybe. Slightly off. So 15.6 less than x less than 19.8 simply means we are trying to find the probability that the weight of the turkey would be between 15.6 and 19.8. And what is the lower end point of the area? 15.6. The upper end point of the area? 19.8. The mean standard deviation would be the same. What do we get?
0.5994.
And in case, if you forget the instructions on how to use the calculator, the back of the textbook, it shows with pictures and stuff, so you can always go back at the end of the chapter and you can look at it. Okay. Everybody put your calculator down. You cannot use your calculator. What is the probability x would be greater than 110?
Approximately 0.
Approximately 0. Why approximately, Benson? I would think it is 0.
You never know, there could be a turkey that's greater than 110 pounds.
It's a turkey.
So what? A GMO turkey. Doesn't it? I mean, it's a thing that hipsters started, in my opinion. I won't get into that. I'll get very political.
Wait, but you tell.
What?
Do tell us. Wait, what do you mean? It's your
No,
turkey?
don't start, Dominic.
I really want to know now.
Made up stuff. Genetically modified. Your skin gets modified every day as you walk in the sunlight, right? So would you consider yourself to be GMO?
That's not how they work.
Okay, moving on. So that's one of several points that I can make. So what about the probability that x would be less than 1.2? Based on the data that is provided to you.
Approximately 0.
Approximately 0. And Benton is right. I can't say it is exactly equal to 0, which in this case it probably is. It's beyond machine position. It will be 0, but who knows, right? So very, very close to 0. Same here. What is the probability that the weight of the turkey would be less than or equal to 110. Go ahead.
Approximately 0.
Approximately 0, okay.
No, it would be 1.
Okay.
Approximately 1. Wait.
So it would be 1. And as I said, that should be 0 by all means. Mathematically, it will be 0. I'll take that approximation out. Here, though, it will be approximate. So you just have to think about it logically. If this is what we know, and the weight of the turkey has this distribution, mean of 19.4, standard deviation of 1.5, and there is no way that you could see a turkey, with weight more than 110. Same over there, but here, if I went and bought a turkey, what are the chances that its weight would be less than 110 based on the sample that we have, based on the information that we have? It's guaranteed, right? Because I know they all lie over here about 19.4, so it is a certain event. Does that make sense? Certain things do not require a calculator, it just requires the mind. Good? So the Z-score simply tells you the number of standard deviations you're about, away from the mean. So I could go back to the real number line. And write down all of those values. So how would I find that particular value on the real number line? That particular observation is one standard deviation away from 19.4, so its value should be?
More, greater than.
No, it won't that value. It's one standard deviation above 19.4, 20.9. This value is 2 standard deviations from the mean, so that would be 22.4. And 3 standard deviations from the mean, 23.9. Yes? And we could do the same thing on the other side. So 1 standard deviation below the mean, so you've got to subtract 1.5. That would be 17.9. Subtract 1.5 again, you get 16.4. Subtract 1.5, 1.5 is the standard deviation, you get 14.9. Okay. Great. Now, you have a Z-score of 1.29. We could assess this in a couple of ways. One, I could think about the property of Z-scores and say if a Z-score is positive, it has to be above the mean. So it can't be less than 19.4. Yes? That's one way of thinking about it. Another way, if you draw a picture like this, where does 1.29 lie? It lies over here. And is that value less than the mean? Absolutely not. So, no. As I said, we are going to do this using the calculator, but I'm going to guess based on the picture that I have. So, oftentimes in practice, before you do any project, you just have to sit down, think about it, then use computer or whatnot. This way, don't waste time. So, what is its weight? It's 1.29, so it has to lie between 1 and 2. 1.29, yes. So if you go back, the weight has to lie between 20.9 and 22.4, yes. And it is more likely that it is closer to 20.9 rather than to 22.4. My guess,
21.2.
bet my mind, baby. I actually thought of 21.22. Great. What percent of Thanksgiving turkeys weigh less than the turkey mentioned above? So 1.29, again, it's right here. Yes. If you remember the empirical rule, you will know the answer immediately. But since 1.29 is one standard deviation away from the, 20.9 is one standard deviation away from the mean, one z-score away from 0, 1.29 is right there. So 50% plus 34%, that's what the empirical rule states, and a little bit added to that. So I'm just going to guess
85.4.
It's just a guess. We'll do this using the calculator. Let's see if we can connect the dots. What is the percentile of this turkey? I'll give you a hint. This is related to the previous part.
14.34.
You were so good. What does bio P86? So the percentile tells you the percent of turkeys that are below the current turkey that you have. So I know from part C, 85.76% of turkeys are below, so it has to be P85.76, approximately P86. That's just a guess. Okay, so without a calculator, just by using our heads, we've come up with all these answers. We don't need a calculator to answer that, that's obvious. Let's find the other values using a calculator. Okay, so we want to find the weight of the turkey. How do we find it? Well, we simply use the formula. And what is the formula? Sorry, wrote it wrong. The mean plus the standard, z-score multiplied by the standard deviation. What is the mean? The mean is 19.34 plus 1.29 multiplied by 1.5. And what do we get?
$21.335.
21 point,
335.
so close. Not a bad guess, yes? Now we have to find the percent of Thanksgiving turkeys that would weigh less than the turkey mentioned above. So I know it is 21.335, it's right here. And I want to find the percent below. How do we find the percent below? Simply means the probability that we're trying to find of this turkey, of turkeys less than 21.335 pounds. So we're trying to find the area under the curve. Normal CTF. What is the upper value? Upper would be 21.335. What is lower? Negative E9. Oops. all we're doing is finding the percentile, so, or probability. So it comes down to 0.9015. We were way off. Our guess was off. But the correct answer is 0.9015, which would mean, what percentile would it be? Be 90.15. We were quite off, but we weren't awful. So, not bad, all things considered. Does that make sense? So, with normal distributions, oftentimes you can guess stuff even before you start the problem. I don't know what part this is. J. So now we want to find P50, P32.15, P64.84, P91.77. P50 is 19.4. We want to find P32.19, and we are going to take a guess. What does P32.19 mean? 32.19% of Thanksgiving turkeys would lie below this particular turkey that stands in the position of P32.19. Okay.
15.2.
What?
15.2.
Okay. We'll get to that in a second. So could P32.9 be there? How about there? How about there? How about there? Maybe. But how about there? No? You don't think so? Okay. So my guess is going to be $20.11. Oh, sorry. Never mind. 18.71. How about that? Definitely has to be less than the mean. Okay. P64.84 would mean 64.84% of all Thanksgiving turkeys would lie below this one. You know, when you get your turkey or when your parents get a turkey, ask yourself or ask your mum or dad, what percentile is this? They'll kick you up. Or be proud of you, depends on the parent. P64.84, 64.84% of the turkeys would lie below this particular turkey. So where should it be? I am going to say it has to be right there. Agreed? Give me a guess.
19.89.
19.89. Okay. And lastly, P91.77 would simply mean 91.77% of all Thanksgiving turkeys would be less than P91.77. Well, where should it be? Maybe there? Perhaps. We'll take a guess. What do you want to guess?
21.4.
21 point?
22.1.
22.1, okay. We got two guesses. What was yours?
I was gonna say 21.9 something.
Okay. This Jersey might be closer, we'll see. Now, we want to find those values, that's just, using our head, but there is a proper way to find this. If you have your calculator, go ahead and grab it. In this particular problem, we're not trying to find a probability. What we're trying to find is the weight of the turkey. In other words, we want to know each of these numbers on that line. We don't need a probability. Probability is given to us. In this case, 32.19% would lie below this particular turkey. 64.84% would lie below that turkey, and so forth. So the probability is given, we're trying to find the weight of the turkey. But sort of as an inverse process, press second bars, and you see option 3 that says IN mean norm. That means inverse normal. It is going to give you the number corresponding to the probability below. Keyword being below. The newer model would have the option of right, left, or left, center, right. It's like a game. But it's always best to look at the area to the left or the area below. So what percent would lie below this turkey? 32.19%. In other words, it is 0.3219. We need the mean. What is the mean? 19.4. We need the standard deviation, 1.5. Close paren, enter. That turkey is about 18.706. How about that? I need to get a PhD in statistics. Same, second bars, option 3. The area below that turkey, and what is the area below that particular percentile? It's 0.6484. So 0.6484. Mean, standard deviation. We get 19.97. .77% lies below that turkey, which is percentile 91.77 turkey. So 0.9177. The mean is 19.4. Standard deviation is 1.5. 21.48. Value was closer. Does that make sense?